Okay, so in this video we are looking at the collision theory, and this really answers the question as to why do reaction rates vary under certain conditions, right? And remember what those conditions are. They were temperature, catalyst, surface area, concentration, and pressure, as well as the nature of the reactants that you don't have much control over, which is the last one. Okay, so let's look at the definition of the collision theory. It says, collision theory is a theory that explains how chemical reactions occur and why reaction rates differ for different reactions. The theory assumes that for a reaction to occur, the reactant particles must collide. That's number one. Remember, it's collision theory. That's the first thing that's incredibly important in this definition, is that we require a collision. Okay, let me just take a different color. They must collide. But that only a certain fraction of the total collisions, these are called effective collisions, okay, actually cause the reactant molecules to change into products. Now this is because only a small number of the molecules have enough energy and the right orientation, okay, at the moment of impact to break the existing bonds and form new bonds. So I've sort of highlighted the important words in this definition because, we need to break it down from these definitions. Number one, you must have collisions. Number two, you need effective collisions. Number three is an effective collision is one that has enough energy and the right orientation. And finally, the combination of having the right energy and orientation allows us to break existing bonds and form new bonds. That's really what the collision theory is. Okay, but those sounds like a lot of words. I'm going to simplify it for you in a moment. Now, as one chemistry teacher once upon a time told me, let me see if I can find two pens. So I've got two pens here. As you can see, these are pens, right? Let's imagine that these pens are particles and they are in a vessel or a closed container. Let's assume that, this area in front of me that you can witness and see, that is my closed container. Oops, sorry about that. Let me just try and expand the screen over here. Okay, it doesn't seem like I can move it. Just give me one moment. Okay, so we've sort of enlarged the screen there a little bit. So for the purposes of this demonstration, let's imagine that the screen that you can see and witness is my closed vessel. Let's imagine that these two things are particles, and they move around. They move around in this closed vessel. Okay, the space is quite small here. Let's make this a little bit bigger. Okay, let's imagine that these two things are particles, right? So these particles float. Now the collision theory says as you float, you need to collide, right? So there are collisions. Okay, number one, there are collisions. Now not every collision is going to be what we call an effective collision. Now effective collisions are the collisions that collide appropriately. Think of two cars, if they make an accident, if they knock into one another, if they collide head on, face to face, that's going to be the worst collision. In this case, is going to be the most effective collision. So when these two particles collide, what we really want is we don't want a collision that just touches and you float off, because this doesn't allow for the correct orientation, right? What we really want is we want a collision that happens like this, a collision that knocks each other. Okay, collision that knocks each other, right? With the correct orientation, like this. And that's a collision in which we can say, okay, there's the correct orientation. These two particles are now ready to break existing bonds and form new bonds. We call that process the time when they make a baby, right? If you want to remember that, it's make a baby. There needs to be the correct orientation and enough energy to make a baby. Okay, so in this case, when they break new bonds and they form new bonds, we call that process or that stage of the reaction the activated complex. Okay, so just think about it. If you have to knock somebody, some collisions are going to be more successful, more effective, the more severe they are if it was an accident. And in this case, it's going to be effective if they knock on, head on, the correct orientation, enough energy. Now in the vessel, as you can see, they knock. Not all of these collisions are going to be effective, because if you just touch and you move on, they don't get together to really make a baby or start the activated complex. Okay, so what does the collision theory assume? It assumes that for a reaction to occur, particles must collide. But only collisions that are deemed to be effective will be collisions where an activated complex is formed. That is the stage in which new bonds are formed by breaking existing bonds, aka the activated complex. What is the definition of an effective collision? It is a collision in which we have enough energy and the correct orientation.